Hello everyone! Today's theme is testing the difference between two means of dependent samples. In this video, I'm going to talk you about the importance of this topic, give a detailed explanation, and show how to solve the problems. First of all, I want to remind you that in order to find the difference between two means of independent samples, we can use both of c-test and t-test. But when our samples are dependent one, then only t-test is acceptable for us. So then, how to know whether the samples are dependent or independent? The samples are independent when the values of the first sample are not related or somehow paired with the values of the second sample. The samples are considered to be dependent when the values are related or paired, merged in some way. For example, the real estate prices in the US before and after bubble burst are considered to be dependent, because the same samples which are real estate prices are present in both groups. If we take the real estate prices in the US and Germany, then the samples will be independent. The dependent t-test compares the means of two related groups to determine whether there is a statistically significant difference between these means. For testing, both populations must be normally distributed or approximately normally distributed. If we don't know whether they are normally distributed or not, we are needed a sample size at least 30 to quote the central limit 0. So, why is it important to know the t-test for dependent samples? How is it useful in real life? Actually, in nowadays, we always experience to test something. For example, our weights before and after eating bishparmak, or our ability to remember before and after memory games, memory programs. So the same thing with specialists who have to know whether the productivity of land, for example, has increased after fertilizing or not, or whether there is significant difference on the sale after advertising the product on the TV. So this kind of testing provides specialists with essential information which is needed to make decisions. Besides them, the researchers and scientists are considered the main users of dependent t-test, because before implementing something, for example the drug, the medicine researchers first of all experience this kind of drug for one sample of patients and observe the results. Comparing and determining the differences by using dependent t-tests, you can exactly know is it effective or is it necessary to work on improving the composition of
The general
medicine.
procedure for testing the difference between means for dependent samples involves several steps. The first step is stating the hypothesis and identifying the claim. Our null hypothesis always states that there is no change between two sample means, so the difference of the mean is equalized to 0. For alternative hypotheses, there are three possibilities. You may claim to have negative differences for left-tailed test, positive difference for right-tailed tests, or you could be more conservative and simply claim that there is a difference so that the true mean is not equal to 0. In the second step, we will find the critical value using degrees of freedom, which is equal to n-1 and a significance level. The next one, computing the test value using formulas. First of all, we should find the differences of the values of the pairs of data. So the next step is to calculate the sample mean of the differences. Since we use d for differences, we will use d bar for the difference mean. As we know, we will add all n differences and divide by n. Then we need to find the standard deviation of sample for differences by this formula. Finally, we will calculate the test value. In the first step, we will make decision whether we should reject or not reject the null hypothesis, and in the fifth step we will summarize the results. There is my example. A composition teacher wishes to see whether a new grammar program will reduce the number of grammatical errors his students make when writing a two-page essay. The data are shown here. Can it be concluded that the number of errors has been reduced? The alpha level is equal to 0.025. So, in the first step, we will state the hypothesis and identify the claim. For the null hypothesis, the mean of difference is equal to 0, because we will assume that there is no significant difference between two means. For the alternative hypothesis, we will claim that the errors have been reduced after the grammar program. To claim this statement, the mean of errors before must be significantly more than the mean of errors after. So, for the alternative hypothesis, the mean of difference will be more than 0. So in the second step, we should find the critical value. To do this, we are needed the alpha level, which is equal to 0.025 in our case, and degrees of freedom. From the formula degrees of freedom, we can find the degrees of freedom in our case is equal to 5. The intersection of these values in the table gives us the critical value. So the critical value for right-tailed test is 2.571, and the critical region and the distribution curve is the right side of 2571. To compute the test value, it's easier to make the table in such way, and following the steps of finding the test value, we will find the mean of differences, standard deviation, and test value, which is equal to approximately 2.236. The decision is not to reject the null hypothesis at 0.025 significance level, since our test value was less than the critical value, and it has fallen in non-critical region. So, we will summarize the results as following. There is not enough evidence to support the claim that the number of errors have been reduced after grammar program, and the difference is not significant. So let's consider p-value method to make the decision about our example. By using degrees of freedom and test value, we indicated the p-value, which is closer to 2.571, and it gives us the tail probability, which is equal to 0.05, and this value is more than 0.025, which is our alpha level. So our result will be the null hypothesis cannot be rejected because p-value is more than alpha level. To make the decision about the significance difference between two means, we can also use confidence intervals. How the result will be concluded using this method? When we are hypothesizing difference of 0, if the confidence interval contains 0, the null hypothesis is not rejected. If the confidence interval doesn't contain 0, the null hypothesis is rejected. Here, given us the formula of confidence interval for the mean difference, and we should find the 90% confidence interval for the given data. Our difference of mean is lied between minus 0.2245 and 3.2245. Our result will be not to reject the null hypothesis, since 0 is contained in the interval. So, to understand this topic fully, we also should know about the last thing and important one. How the mean of difference will be changed when specific difference is given. So in this case, first of all, the mean of difference will be equalized to this value in null hypothesis, and given value will be substituted in the test statistic formula for mu t. For example, if a dietitian claims that people on a specific diet will lose an average of 3 pounds in a week, and the specific difference will be 3. So for null hypothesis, the mean of difference is equal to 3. For alternative hypothesis, the mean of difference will be not equal to 3. So that's all for today's topic. I think I could explain clearly. Thank you for watching. Goodbye.